rocks. Wonderful.
Whatever happened to that dude that built the car that ran on water? Who died?
I don't know. I don't know who you're talking about.
He died?
Two guys tried to make water. One of them passed on. The other one got put in a mental hospital.
For trying to make a car that runs on water.
Basically,
it's like solar powered, and you're.
Basically, the conspiracy theory says that the oil company or somebody came and offered him a big check that would damage their products, and then
I would believe that
he refused it, and then they said
he shouldn't have done
they took him to court, and he got declared insanity for not taking a check, and
he died poor. That all sounds pretty believable, but the technology for water cars isn't great. And you want to know how I know? Because I literally have a water car right here. It's just not that great.
Like a water burger?
Yeah, it's like a little toy thing. You fill this up with water. It's got a solar panel. You hook up the solar panel to it, and the electricity from the solar panel basically does a chemical reaction with the water and creates energy.
Let's make that a little project. Let's go charge it up.
Yeah, go. You just write up the chemical formula, and we'll make it a little like educational. And once you get that done, then we'll do the project.
How do you
you got research to do first. We don't get to just play with toys without doing research. Google it. But the point is, I can make like a little toy car go. You're not gonna make a car that runs off of water and electricity that can actually drive around on highways and push around like airbags and stuff.
He did make one that he could ride.
Oh, I believe it. Yeah. There's one right there. I believe you. You doubt me? Like I could stand on that. It could push me across the room. You don't know what's going on. You don't know what's going on. But yes, if you want to talk about engines or different types of propellant systems or stuff like that, I'm here during activity period. So working on today. Everybody, heads up, focus, and close your Chromebook. Hey, talking to you too. Close your Chromebook. Yeah. So what we're talking about today is sedimentary rocks. We've already gone over igneous rocks, which are from fire. You have to be melted, so you got to have magma or lava. We talked about metamorphic rocks, which mean to change. So they've changed from some other rock type through heat and pressure and become a new special rock called a metamorphic rock. And now we get into sedimentary rock, which, let's be honest, outside of volcanoes, the sedimentary rocks are the cool rocks. The sedimentary rocks are the rocks that people go on vacations to see. And that sounds stupid, but literally people go to vacation in, like Arizona, New Mexico because of the nice scenery. And that scenery is the rocks. And so what you're looking at here, I would say this is probably the Grand Canyon, but China has some really nice hills like this. And so it could also be China. To be honest, it's probably Arches National Park now that I read the first words underneath it. But you never know. It could literally be anywhere. It's just a picture for sedimentary rocks. So they talk about Arches National Park at the very beginning, and specifically this famous arch that they have here, which is part of why it's called Arches National Park. And this arch has a very unique history, which kind of goes right into what I learned a lot about, which is oil and gas exploration. So when I went to OU, they heavily focus on oil and gas exploration. And what happens here, if I can do a quick little illustration of this, lights coming on. They kind of have, in a way, underneath the picture, they describe the history of what's going on with this arch, but it doesn't kind of help you visualize it. So imagine many years ago, this part of the country is underwater, or there's a giant lake or an old ocean that's kind of drying up. And what we're getting on top of these different layers of rock is we're going to get a salt layer deposited. So I have a really thick ocean, or like a saltwater lake, like one of the Great Lakes. And something happens, sea level drops, the landform changes, that ocean gets cut off from the rest of the oceans in the world, or the lake gets cut off, and it starts to evaporate. And when the lake evaporates, the water goes away, but all the salt stays. So what you get is this nice thick layer of salt here. Let me just write that in there so we see that this is different from the rest of them. This is my salt layer. So over a long time, and this would essentially be what you have. Is everybody familiar with the salt flats in Bonneville? Yeah, there's this place called the Salt Flats. It's up in like Utah. There might be one in California too. It's an old lake, and the lake dried up, and all the salt, because it was a saltwater lake, is left behind, but it's really, really flat. And so you got a really, really fast car or motorcycle that you want to race, but you need a road that's super long and super straight and super flat. You take it out to the Salt Flats, and you can get up going like 100, 200 miles an hour, never have to turn or go through a stop sign or worry about other cars or anything like that. So we do have these. They're around. They're nice, kind of like tourist attractions. Well, it's just open land. I don't know that it costs you anything. Dude, we'll just Google it later, okay? So we got the salt. You got your salt flat, and over time, I'm going to get more layers built up on top of this because sedimentary layers are just going to continue to build up. So I get more and more layers building up on top of this until I have, several hundred feet, if not maybe close to a mile of material up on top of my salt. Now, what's going to happen? Do these rocks weigh a lot? Yeah, rocks are heavy. And if I have like hundreds of feet of rocks on top of me, they're going to be pushing down quite a bit on the layers that are below them. And normally that's fine because what are the layers that are below them made out of? They're made out of more rock. And rock's pretty good at holding heavy things. That's like its whole life. But salt is different. Salt is not strong. It breaks very easily. It's a relatively soft mineral. If you go back to sodium chloride as a mineral we didn't really talk about minerals yet. But when we do later, sodium chloride is a very soft mineral. It's also called halite. It's like a hardness of about 3. So it's almost as soft as like your fingernail. So very, very soft, not very strong. When all these rocks push down on this, they're going to win that fight. And this is going to get squeezed. But just like anything else, if I squeeze here and kind of pinch this down in, where's the salt going to go? It's got to go out. It's got to go somewhere else. And so what I get with this salt layer is I get areas that get pinched out. So the layer gets pushed down. And what happens is the salt goes in either direction and kind of gets pinched out. So for every area that I have that's pinched down and the layer above it has kind of squeezed it, I'm going to have another area where the salt gets pushed into that layer and kind of gets pushed up. Does that make sense? So for every squeezed area, I'm going to have like a bulging area. And so this area is going to be my little bulge. Now, after a certain amount of time, erosion starts to happen. Things kind of get uncovered. I'm getting my layers eroded away and weathered away and stuff's coming off. And eventually, my water level comes down, my erosion happens. But what I have is a layer of salt here and a layer of hard rock or sedimentary rock above it. And the sedimentary rock is not going to be eroded as easily as the salt. Will salt be dissolved by water? Yeah, so once this gets up to the surface, with just a little bit of the rain, the salt dissolves away really easily. And so that's actually what's happened here with this arch. This hole, at some point in time, way long ago, this hole was actually a pinched roll of salt. So we had a salt layer right here. All the layers were built up on top of it. And on either side of this arch, the layer pushed in and pinched the salt off on both sides. And the stuff that was in the middle got squeezed. And it got pushed up into this kind of like bubble that came up. Once everything else erodes away, that bubble gets exposed at the surface. And all the salt is going to dissolve relatively easily. Probably wouldn't take more than a couple decades. You got a salty river downstream. And all your salt dissolves away. And what it leaves is this nice hole. And then we as humans come behind it and we're like, oh, this is special. Like, this is so magical. And we make a big deal out of it until one day someone does a little bit of work and they're like, yeah, that's just salt. That was a salt bowl. Why is this important? Why do people get paid to study this? How did anybody ever figure out that, yeah, that was salt there, and that's why we have this giant, cool-looking arch? Salt is actually very important for oil and gas because what happens, turn the lights on real quick, just so everybody can see this. You can get really big salt bulges in a way, and so I can have a like bubble of salt that kind of comes up like this through a bunch of layers. And we see this all the time in the Gulf of Mexico because Gulf of Mexico has a bunch of little salt layers like this. And the more stuff you pack on top of it, the more it gets squeezed, the more it gets pushed around. And so if I have a big salt bubble that comes up through a bunch of other layers, what I look for in oil and gas is I look for the layers that run into it. And they're going to all like peak up around the salt kind of like this because it pushed them up just a little bit. And so I have these little peaks of these layers that just kind of run into my salt. And right here in these corners, right here, that's where my oil and gas is going to go. Because oil and gas always wants to move up. It's less, or it's more buoyant than the rock around it. The rock is heavier. So any oil and gas in this layer that happens to be here is all going to migrate up into this corner. The layer above it is going to trap it, and the salt is going to trap it. And so when we drill, we want to drill our hole right down into that area, and that's what we're looking for. And so salt may not seem like a big deal, like especially when we're talking about geology. We're looking for rocks, we're looking for oil, gas, metals. But salt often can give you like a trap or a way for you to find where your oil and gas is at. And so one of the big plays in the Gulf of Mexico right now is looking for these salt domes. And anywhere you find a salt dome, you pay your people to look really closely at the areas right next to it because you can find really big oil and gas fields in those areas. So that's just a little side thing. The art story is cool, but after you hear it, you're like, that's cool. But when we talk about salt and you know that ExxonMobil is making like literally billions of dollars off of salt plays last year, then it becomes, that's a little bit different. It's a little bit more important. Money's involved. So Arches National Park is really cool. If you ever get a chance to go there, I would go check it out. It's in Utah. So they just talk about how nice Utah looks with all the sedimentary rocks. It's where a lot of films are made because of the scenery. And obviously, if you've ever been to the Grand Canyon, who's been to the Grand Canyon? Nice. Pretty awesome. Yeah.
I flew over it in a helicopter, but I didn't go in the Grand Canyon.
Oh, really? I imagine flying over in a helicopter is pretty cool too, though. Because you get to see like a different perspective of it. But yes, the Grand Canyon is extremely nice from what I've heard. I have not gone. And if you ever get a chance to go, I would go and check it out. Nice sedimentary rock layers. But no, the Grand Canyon is like all sedimentary rock layers. So when you see those red layers alternating all the way down the Grand Canyon, that's what you're looking at. So what we want to talk about with sedimentary rock layers is how they form, how we categorize them, and what we're looking at. So remember, when we talk about sedimentary rocks, everything used to be like a tiny little piece of something else. And we're talking about sediments. Sand, mud, dirt, gravel, the river rocks that you see in like mountain streams and rivers, all that stuff can be cemented together in all sorts of different ways to create a sedimentary rock. So anything that's made up of pieces of other stuff, that's a sedimentary rock. Now, all of those pieces essentially come from chemical weathering. So we've got weathering happening. It's being broken down into smaller and smaller pieces, either mechanical or chemically. And then I need to create my rock. Now, the two ways you create rock, like how do I take sand and turn it into a sandstone? I need these two things, compaction and cementation. So I got to squeeze it and I got to glue it all together. And the earth is naturally going to do that for us, but without those two things, I still just have loose sand. And so that's what I'm looking for. I'm looking for compaction. I'm looking for cementation. That's going to help me create my rock. We don't need to watch that video. So how do we classify these? We have roughly three different classifications. The first one is clastic. Clastic sounds like classic. So the way I remember it, a classic sedimentary rock is the one that I'm thinking of that just has a bunch of pieces of other rocks. So like a sandstone, where it's literally just a rock made out of sand. That's the kind of classic sedimentary rock I think of. It's composed of fragments of pre-existing rocks. Now we have two different other types of sedimentary rocks. There's chemical sedimentary rocks, and kind of as a subcategory underneath that, you also have organic sedimentary rocks. Chemical ones are going to be like this. This salt here. Where did this salt come from? Where did I tell you the salt came from? Yeah, a dried up lake bed. So this is more like a chemical thing. I've had water, the water evaporated away, the salt is there. The salt was never part of like another rock. It's not like salt that eroded down from the salt mountain and came down into the valley. The salt was just a chemical part of the ocean or the lake that happened to be there. So that's different from clastic, which is like from pre-existing rocks. This salt came out of water. That's going to be a chemical sedimentary rock. The other part of this is organic, like a pearl. Pearls, technically, somewhere in there, fit inside one of these categories. A pearl is naturally made. It's not a part of a pre-existing rock, but it is made of minerals. It is made of chemicals, and that pearl can become part of the rock record. And so at some point in time, you have to do that. The same thing goes with shells. Clam shells, shells of all sorts of marine animals. When they die, their shells fall down to the bottom of the ocean. They get incorporated into sedimentary rock. They're not part of a pre-existing rock, so they're not clastic. It wasn't like a chemical reaction. It was actually an animal that made the shell. So it goes in the organic category. The last thing would be coal. Coal is a sedimentary rock. What is coal made out of? Made out of what?
It was made of dead organisms that were eaten up.
Yes, specifically plants. So just know. Just know that what we told y'all when y'all were kids, and I was told this too, that fossil fuels come from fossils, right? It's like dinosaur bones. That's not true at all. There were never enough dinosaurs or even like living animals to create the amount of oil and gas that we have. Oil and gas and coal come from plants. And those are the kind of fossils that we're talking about, plant fossils. And so to get coal, you essentially have to have millions of years of like swamp piled up on top of each other and kind of cooked in a certain way. That'll get you coal. And so that's going to be another organic one. So their examples here. Chemical sedimentary rocks are going to be like salt, like they say, halite, travertine and gypsum and chert. These are all just different types of quartz. Well, gypsum's not, but travertine and chert are. And gypsum's another type of salt. It's just not like the salt that we use. Organic rocks, like I said, are going to be coal and rocks made out of shells. So like chalk and coquina. Coquina is literally just like broken up pieces of shells off the beach. And then your plastic rocks are going to be made up of actual pieces of other rocks. Sandstone, shale, which is like a mudstone, and then breccia and conglomerate are like your big pieces of broken up rocks. They almost look like cement. Okay, so they go through chemical stuff. I don't know that we're going to talk about this too much. Just know that when they talk about chemical stuff, we're really talking about things that came from water. So like a stalactite or a stalagmite, right? Stalactites and stalagmites have the rock dissolved into the water. The water drips down through the caves, and then every drip that comes down leaves a little bit of rock behind, and you get these nice stalactites and stalagmites. Those are a chemical sedimentary rock. But just imagine they don't always have to be dripping down from the top of a cave. I can have the same thing happen to that water in the middle of like two rock layers or at a lake bed that's drying up. It doesn't always have to be the stalactite, stalagmite kind of formation. So then you go to organic sedimentary rocks. And like I said, this is going to be some sedimentary rock that was made by a living thing. And we don't really have a better place to put it, so we made an organic category. It can be shells of living things. It can be plants that make up coal. It could even possibly, pearls are a little bit weird. We would argue about pearls, and there's not a definite place that you can put pearls, but anything that was made by something living but now is part of a rock, that's going to be your organic or biochemical sedimentary rock. And then down at the bottom, clastic. Clastic is going to be the easy one. This is made up of pieces of rock that we know. Even using terms that we know, like gravel, sand, mud, silt, clay. These are all actual sizes of pieces that are going to go into your rock. And they actually have them listed here. Clay, the smallest, extremely, extremely small. Then you go up to silt, fine sand, medium sand, coarse sand, very coarse sand. Did you know there are so many different types of sand? Yeah. In Texas, we don't have a lot of sand. If you lived in the desert, you'd probably be very aware that there are lots of different types of sand. Gravel, pebbles, cobbles, and boulders all have very specific sizes and millimeters that we can kind of sort them into. So if it's a broken up piece of another rock at any point in time, that's going to be a clastic sedimentary rock. Just think like a sandstone or a mudstone. It's made out of something that was already there that's just kind of been broken down into smaller pieces. Then, they got a little bit of texture. You know the difference between fine and coarse, right? Fine grain is going to have really tiny grains that you can't really see. Coarse grain is going to be larger grains that you can see and you can feel. So like a coarse grain would be like a sandstone or something that has gravel or cobbles in it. A fine grain is going to be something like mud. Like when you look at mud, can you see the individual like particles of the mud? Nah, it's just like a ooze, like a brown ooze. And so that's what they're talking about here. Fine grain is going to be really small. Coarse grain is going to be big enough that you can see and feel the individual pieces. Kind of for example, fine grain rock, coarse grain rock. With the coarse grain, I can see all the different pieces of it. I know that it's made up of pieces of other stuff. And then lastly, features of sedimentary rocks. This is the important stuff. Let's refocus. This is the part that I really want everybody to understand. Sedimentary rocks are one of the most important and most interesting rocks because the layers that they form are literally the history book for the earth before people were here. So when we talk about history, right? History starts when we started writing things down as people, right? Before that, just who knows what happened. I don't know what the animals were doing or what the trees were doing. But once we started to get language, we started to write stuff down. That's where history begins. But the earth has a history long before we were here writing stuff down. And it's actually recorded like a book. Every single page is a layer. Every single chapter is an entire rock package. And I can even have pages missing and stuff that's not there. If I had something you wrote it in between this layer and that layer, that's like pages being ripped out. Once they're gone, I can never read those pages again. That little section of history for this area of the world is like deleted. But for all the pages that are still here, I can go in and I can find out all sorts of stuff. It just looks like rocks now, but if you have enough science background and you know what to look for, I can go in and find out what kind of things were living in this time frame in this area of the world. How much oxygen was there? How much water was there? If certain things exist in this rock, I can tell you which direction the wind was blowing and which direction the river ran 100 million years ago. Any dinosaur bones or any human evidence from old civilizations have to be in sedimentary rocks. If they were in igneous rocks, they'd be melted. They had to go back to magma and lava. If they were in metamorphic rocks, they'd be destroyed from the heat and the pressure. Every dinosaur bone, every human artifact, every arrowhead, and old hut came from sedimentary rocks. This is our history here in like the Earth's in the Earth's little history book. So what are some features? They have stratification. Stratification is the layers. If you see the layers like you see in the Grand Canyon, like in this picture, or all the way up in the top, that is your stratification. So each one of these is a stratified layer. If we go back down, I lost my place. Classic sedimentary rocks, texture, here we go. What else do they have? Graded bedding. The graded bedding is actually pretty cool. So what happens here is, I forgot to bring my camera back over, but I can do this. The creeks around here. The creeks always full around here? No. In the summertime, they're dry as a bone. When it rains, they fill up. They go and fill up all the ponds, and there's a little water in there sometimes. But then after a couple weeks, it's gone again. What we get from that is a very interesting thing. So when the river is high or when the creek is high, the water runs fast, right? And when the water runs fast, it's nice and brown. It's got all sorts of dirt and mud and all sorts of stuff picked up. And so think about like flooding rivers. When the river's flooded and the water's moving fast, it can pick up big stuff, right? It can pick up like giant trees. It can pick up your car and sweep it down the river. When the rivers flood really, really bad, sometimes you see whole houses in there floating down the river, right? So when the water's running fast, it can pick up big stuff. And when the water's running slow, it can't pick up anything. It's just like a trickle of water. It's not even going to move the sand that's underneath it. So when I get a big rain, the creek or the stream picks up all the big stuff. And as soon as that water starts to slow down just a little bit, all the big stuff is going to fall out. So what I get is a layer of my bigger particles. And so as soon as that velocity slows down just a little bit, the big stuff comes out. And then you wait another day or two, and there's no more rain, and the creek starts to dry up, and I go from a big full creek to maybe like a half full creek, or maybe like a quarter full. The water's flowing even slower. All the big stuff has already fallen out. Now I get my medium stuff. So now I get medium little ones start to fall out, and I get a medium layer, which I'll just try to do quickly. So I get this little medium layer, and then finally, all the fine stuff falls out, and I get only the little fine stuff. And so that's that graded bedding, big to small, over and over and over again. Every time it rains, I get that cycle that shows up again. That tells me about the history of that creek for different times of the year. It's a history book for sure. Think about that. Hello.
Wait, what happened?
Wake back there, Brandon. You wake back there. Yeah. Hello, come on in. Where you going? You want to come do some sport geometry? No, you don't want to do it. Let me see progress reports. I keep forgetting about progress reports. Am I still recording? Grades.
Just bring this one.
IPRs. Fifth period.
Did it say rock and roll?
All these. Yes, we're going to talk about it. Thanks for spoiling the video. I'm just messing with you.
Mr. Bailey, what did I miss yesterday?
We went over a test review, which we'll go back over again today. So,
What do I have to make up?
just the review. Hold on, I'll give it to you in a second. Print. Preferences. 14. Awesome. Okay. Prince.
Why? What's wrong with you? Okay. Let me do this. Am I still recording from last period? Sorry. They're going to be like,